Okay, we're getting started again. Dimensioning counterbores and spot faces with fillets. Counterbore hole with a fillet radius specified. So this is, you have a top view, and in a front view it's a section view, and then down below you have it's been enlarged to scaled up, and that's how you would put the dimensions on. When a fillet radius is specified for a spot face dimension, the fillet radius is added to the outside of the spot face diameter. So there's how, on the right, there's how you would do a spot face. If you look at the symbol on the left hand side, that's a counterbore. It says the diameter of 5 through counterbore, diameter 10, radius of 1, the depth of that hole of that counterbore is 0.25. All right, yeah. And on the right hand side, you have a diameter of 5 through a spot face, diameter of 10, radius of 1. Okay. Curves. I'm not going to go into curves too lot. This video is getting kind of long, and we're not going to be doing any of this. Just look at it, be aware of stuff. Might be a question or two, especially down there on the right hand side. It says when angular measurements are unsatisfied, you may give chordal dimensions. So find out what a chord is, and you'll know what a chordal dimension is. Dimensioning round is in slots. Okay. In the upper left there, that's it's basically, you can look at it as a slot, but it's actually a part. It's a link of some sort. And down in the middle on the left, you got an embossed slot, that little racetrack looking thing around the edge. That's a hole in the middle of it, and then it's got a raised edge around the edge, kind of reinforcing the part there. And then you got the same thing in C on the bottom left, only it's an arc. Okay. And on the right hand side, D, you have a slotted hole. That's one way of putting dimensions in there. And then you have another bar, sort of like just it's got a rounded ends and a depth. And then in F is another, like a link up in, like one up in the A. And then G, you got some angular lines there that you have to deal with. Dimensioning threads. Local notes are used to specify dimensions of threads for tapped holes. The notes should, if possible, be attached to the circular views of the holes. So on A there, you have two holes with, there's the same threads. The threads are 0.25-20 UNC2B. And that 0.25 is basically a diameter. It's the diameter of the threads. 20 UNC, that's the number of threads per inch. UNC stands for Unified National Course Threads. And 2B is sort of like a quality type thread. They're the same, but one goes all the way through the hole, and the other one doesn't. On the right hand, on B, to the right, they have a note there. It says M30 times 2. That's basically a threaded rod there. And then you have a threaded neck relief or whatever there. Thread neck, sort of a neck right there on both sides of that middle part. And then on the far right in C, you have a knurl. A knurl is just where you rough up the steel. In this case, it would be steel. You would rough it up so you could grab a hold of it, sort of like for a handle, so you could grip it better. Dimension tapers. So you have taper, which is a conical surface on a shaft or a hole. The usual method of dimensioning a taper is to give the amount of taper in a note, such as taper 0.167 on diameter with to gauge often added, whatever that means. Then you give the diameter at one end of the length or give the diameter at both ends and omit the length. Taper on the diameter means the difference in diameter per unit of length. So those are 4 examples of how to do tapers. Okay. Chamfers. Chamfer is a beveled or sloping edge. It is dimensioned by giving the length of the offset and the angle. A 45-degree chamfer also may be dimensioned. So there are 2A, you have a chamfer of 3 and at an angle of 30. And B, you have chamfer of 3 by 45 degrees or 3 by 3. Okay, 2 distances are a distance and an angle. Dimensioning keyways. Again, I'm not going to go a lot into this because this involves a lot of tolerancing, and we're not going to do this. So, but be familiar with it because you may run into it in 124. The preferred method of dimensioning the depth of a keyway is to give the dimension from the bottom of the keyway to the opposite side of the shaft or hole. So in A, you have a shaft. Okay, and you have a keyway in there. And you go across. B looks like the end of a shaft. But C and D is basically like they did a removed drawing of might be a gear, and the shaft would go inside that hole, and then you put a key, which if you look in A, you see that little circular object on top there. It says Woodruff key seat. That's the key. That's what the key would look like. They would push that key up in there, and it would lock that gear and that shaft together, and it would turn as one. Again, here's that knurl. A knurl is a roughened surface to provide a better hand grip or to be used for a press fit between 2 parts. For hand grip purposes, it is necessary only to give the pitch of the knurl, the type of knurling, and the length of the knurled area. So those are 3 types. One of them is A is a diamond knurl, B is a straight knurl, and looks like C is a straight knurl too. So, but that's how you would dimension those in 3 types. Finish marks. A finish mark is used to indicate that a surface is to be machined or finished, as on a rough casting or forging. To the pattern maker or die maker, a finish mark means that allowance of extra material or metal in the rough workpiece must be provided for the machining. So usually this part is casted. What they do is pour it in a mold and hot steel in a mold, and then they take it to a lathe or something machine, a mill machine or something like that, and they start shaving material off of it. And depending on what the finish is, depending on how much material and how they take that material off. Again, this would be something you'd see in DD 124. take another break.